Hi there. In this video, we're going to go through where the quadratic formula comes from. So this is the kind of thing that maybe you would see once. It's not something that I'm recording expecting this video to get like a million hits. I would be shocked if it did, because it's the kind of thing that you might want to look at one time and then never ever see it again. But what bothers me a lot of times in math classes is that we have the quadratic formula. So the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And your teacher will give that to you to be able to solve a quadratic equation. So you've got ax squared plus bx plus c, and you look at what your a, your b, your c values are, and then you dump them into this formula that kind of comes from nowhere, and it will show you what x is equal to. And so this video is going to take you through the process of where the quadratic formula comes from, other than just the pages of a math book. So it might take a little while. And it does assume that you know a process called completing the square. So if you're not familiar with this process, okay, called completing the square, then what I am about to do is going to feel very, very random. Just why would you do this? And what I'm doing is I'm carrying out this process called completing the square. So if you've covered that at some point in a math class, what is completing the square, then this will definitely be anchored more. If you haven't, it's going to feel very random. Now, what you need to keep in mind here, okay, that's going to basically undergird the entire thing is just do the same thing to both sides. Now that is maybe the golden rule of equation solving. So as long as we do the same thing to both sides, no matter how random it looks, okay, just completely random thing, like why, as long as I do the same thing to both sides, I should be on okay ground. Okay, so keep that in mind. There's also going to be some assumption that you know how to deal with fractions, finding common denominators, and so forth. So if there is a step along the way where I genuinely lose you and you need to be found, please drop a comment, drop a question, let me know. I'll do my best to work through this, and I will see you at the end, as I might tell my own students. So let's start with ax squared plus bx plus c equals 0. So this is the equation we want to solve. And what we want to do is we want to get x by itself. Okay, this is what we want to do here. We want to be able to get the x by itself. And if you've completed the square before, you know that we do not like to complete the square with a leading coefficient. Okay, so we want that to just be x squared, not ax squared. So to get there, I am going to divide by a. All right, and the reasoning here is if I divide this, a divided by a is 1, which is going to give me the 1x squared. And then I have to do the same thing to the other side. So I'll have 0 divided by a over here, which will just be 0. So that is going to be a rewrite. Okay. And now we have it looking like that. Okay. Now, to complete the square, I need to add something to both sides. And I have this on the left-hand side, and I don't want that there. I need something else there other than the c over a. So what I'm going to do next is subtract c over a, but I've got to subtract it from both sides. So now I will have x squared plus b over a x equals negative c over a. Now you'll notice I left this big space here. Like that seems kind of weird. I'm going to put something else there. Okay, I'm going to put something else there. I'm going to add something, and whatever I add, I'm going to have to add it to both sides. So now we've gotten to this spot here. Okay, so we're going to add something to both sides. Now, what do I need to add? This is where, if you're not familiar with the completing the square process, this is just going to seem really weird. But when you're completing the square, you typically will take that middle coefficient, so whatever that is, and you divide it by 2. So we don't usually complete the square if we have an odd number, because if you take an odd number and you divide it by 2, you end up with a fraction. So we typically will complete the square when we have even numbers. Now, I have absolutely no idea if this number is even or odd, but I do know I need to divide it by 2. So we're going to take b over a divided by 2. Now, b over a divided by 2 is the same as b over a times 1/2. And then b times 1 is b, and a times 2 is 2a. Now, before I add that in, I need to square it. So I need to take b over 2a, and I need to square that. And so that would be b over 2a times b over 2a, just so I don't lose anybody there. B times b is b squared, and 2a times 2a, 2 times 2 is 4, and a times a is a squared. So what we're going to add to both sides is b squared over 4a squared. Now, again, if you have never studied completing the square, you're like, why would you do that? Again, you just got to study completing the square. And there's some great ways for you to explore that process using algebra tiles to see how this works. There's some very visual ways to show you how it works. Now, same rule though, remember that key idea, I have to do the same thing to both sides. So if I am going to add b squared over 4a squared to the left, I also have to add it to the right to make sure that I'm keeping that balanced. Okay, so in this next step, I'm going to do 2 things at once. We'll sort of, it's gonna, because we got kind of a mess on the left and we also have a mess on the right. And so we want to make some progress on both of those. In my mess on the left, I am going to factor that. Okay, and in my mess on the right, I am going to try to get a common denominator. And so you'll notice that I've got a denominator of 4a squared, and this denominator only has an a, so this needs the 4 and it needs another a. So I'm going to multiply that by 4a over 4a. All right, so that is multiplication right there. On the right, x squared factors into x and x. And then this is where it gets kind of interesting. This is a perfect square trinomial. And I know that because I completed the square because of how I picked that out. And so this is going to end up being, when I've taught students how to do this, I'll be like, save that number, whatever that number is, because that is the number that ends up being here. So b over 2a plus b over 2a. Now, I kind of want to stop for a moment here because if you've never seen this before, like at this point, your screen looks like alphabet soup, okay? It just looks like somebody opened the can of SpaghettiOs with the alphabet and we just have A's, B's, and C's and they're floating everywhere. So that factoring step, let's take a moment and just explore that a little bit more. X times x plus b over 2a times x plus b over 2a. So just to convince you that this is indeed an okay thing to do, x times x will give me x squared. X times b over 2a would be x times b over 2a, and then you're going to get that again, x times b over 2a, and then that last part is the squaring part, so that's going to give you b squared over the 4a squared, and then this middle part, you've got the same thing twice, so you have 2 of them, 2xb over 2a, but notice that what's squared, those cancel out and you get the xb over a, which is what we knew we had. So if you're like, I don't think I trust you to be telling me the right thing there, I wouldn't blame you. Like, I'm a stranger from the internet, probably, unless I'm not. So you might say, I want to see that works out. So it does work out. So what this is x plus b over 2a all squared. On the right here, remember this is multiplication, so this is going to be negative 4ac over 4a squared, and we have b squared, and that's over 4a squared. Now, I do want you to notice that we have pieces of the quadratic formula coming into place here. So if you think back or rewind the video to what is in the quadratic formula, you know there's like a minus 4ac in the quadratic formula somewhere, and lo and behold, like we're seeing the minus 4ac. Here's the b squared, okay, going on right there. And yeah, so you can see pieces of this coming together. Okay, so on this slide, I'm going to just copy what I had. What did I have? X plus b over 2a all squared. And when I go to write this other side, I'm going to just do a quick little switcheroo. It was minus 4ac over 4a squared plus b squared over 4a squared. And I'm just going to switch the order of the addition. Remember, we can always switch the order of our addition around. So I'm going to do b squared over 4a squared minus 4ac over 4a squared. And that just puts that in the form that I'm like more comfortable with, because it's going to have the discriminant in the right spot. All right, and then we can write that as one fraction, so b squared minus 4ac all over 4a squared. And now you can see I just tossed out the word discriminant there, b squared minus 4ac. Now this is we're getting it. Like, we're seeing pieces come into play. Now, what we're going to do next is we're going to undo this squaring, because remember, we want to get the x by itself. That was the entire goal here. And you'll notice that we have come a long ways in getting the x by itself. So we now are just down to this like 1x here. So it's looking promising. I'm going to undo that squaring by taking a square root. Now, remember that key idea, you got to do the same thing to both sides. But when you take the square root of this right-hand side, you do need to make sure you have that plus or minus there, because there are two numbers that when you square it could give you that answer. You want to make sure you catch both of them. You don't need it on this side because we're basically just undoing the squaring right there. So if you undo the squaring, you will be left with x plus b over 2a. And then over here, okay, what you can do with that is when you take the square root, you're really taking the square root of the numerator and the denominator separately. And this we can take the square root of, okay? And so we'll have x plus b over 2a. Now the numerator there, we're kind of stuck with that. That's a bit of a mess. But the square root of 4 is 2, and the square root of a squared is a. And what I love about that is that just gave me common denominators there. So the last thing that we need to do to get the x by itself is we need to subtract b over 2a from both sides. And I love that I have a common denominator for that. So where does that bring us? That's going to bring us to x is equal to, and we have plus or minus b squared minus 4ac all over 2a minus b over 2a. And the only thing I'm not happy, well, let's go combine the fractions. Like, we got the common denominator there, so we might as well do that. B squared minus 4ac minus b all over 2a. We're almost there, except that typically in the quadratic formula, we don't start with this. Like, we've got the minus b over to the front there. And so I'm going to go ahead and switch the orders. Now, order there. Now, it might be helpful to say this is like plus negative. So I'm going to move the negative with that over to the other side. And so we'll have negative b plus or minus the square root of b squared minus 4ac all over 2a. And there we have it. So that is a derivation of the quadratic formula. That's where it comes from. Okay, so we start with our ax squared plus bx plus c equals 0. And we essentially go through a huge process to get the x by itself. And that process lands us at the quadratic formula, and that process is called completing the square. And like I said at the beginning of this video, this is the kind of thing that you probably like see it one time, you're like, wow, that was cool. It didn't just like come out of the void. The formula does come from somewhere. Would you ever be asked to replicate it? Probably not. This is one of those enrichment things of, okay, I've seen where it comes from and I understand that this formula is anchored well in logical processes. So I hope you found it helpful or interesting. If you did, please give it a like and check out some of the other videos that we have on the channel to enrich your math or to help you out with whatever you're working on. I will see you in the next one.